Hello, Algebra 2 students. Today we're going to look again at the imaginary numbers a little bit, and we're going to see some examples of solving quadratic equations with those imaginary numbers. So let me see if I can make this bigger. Yeah, there we go. Okay, so this is a quick review. I'll attach this packet to your page, but I'll show you there's only part of it that I want you to turn in to me, the practice problems at the end. So let's go through this. This says study the quadratic equation 0 equals x squared plus x plus 2. Where my mouse is. There we go. Computer's being jicky. Okay. Study the quadratic equation 0 equals x squared plus x plus 2. And it asks, can it be factored? If it could be factored, we would have numbers that multiply to 2. That's that third term. And add to 1, which is the middle term. Okay. If it could be factored, we need numbers that multiply to 2 and add to 1. Right. The only thing that multiplies to 2 is 2 and 1. It doesn't add to 1, so it cannot be factored. Can the zeros be found from the graph? So if we look at the graph, go to Desmos, and type that in. What was it? It was x squared plus x plus 2. I got 2x squared there. We learned that solved by graphing, you look for the x-intercepts. If you notice, when we graph this one, it does not have x-intercepts. So the answer to this question, can it be found from the graph? No, because it has no x-intercepts. So we've learned that a lot of our quadratic equations can be solved by factoring. This one can't be solved by factoring. Some can be solved by graphing. You find the x-intercepts. This one has no x-intercepts. It says there are still 2 solutions to this quadratic equation. However, they're not real numbers. They're numbers that are imaginary. This is the symbol that you learned about yesterday with the I. The I represents the imaginary number, the square root of -1. Okay. Something really important to remember is the I is the square root of -1. Okay. When you have, it tells you here, if you have a negative under a radical, you can take it out. That's what we did yesterday. Okay. So then we did some of this yesterday where it says simplify the following complex numbers by writing them in terms of I. So -49, the square root of 49 is 7, and the negative becomes the I. Square root of -121 is 11i. 17 minus 42 is -25. The square root of -25 is 5i. For D, the square root of -3, there are no squares that go into 3. So it's going to be I times the square root of 3. This one, 12 plus the square root of negative, so that -36 simplifies as 6i divided by 2. This number, this number, and this number, all divided by 2. And we really don't need that 1. It's just 6 plus 3i. Okay, that's more of what we did yesterday. Simplifying using complex numbers. A negative under a square root becomes an I. All right, let's go. A complex number is the sum of a real number and an imaginary number, usually written in the form a plus bi. The real part is the a. The imaginary part is the bi. That's hard to read. A is the real part. Bi is the imaginary part. You can tell the imaginary part because it has an I with it. It says write the following numbers in a plus bi form. Identify the real part and the imaginary part. So f is 25. That's just real. There's no imaginary part. If you want to write it in A plus BI form, you could do 25 plus 0I. 25I is just imaginary, so that would be 0 plus 25I. 3 minus 5I, that's already in the A plus BI form. The 3 is the real part, the 5I is the imaginary part. Okay? When you see these numbers written, the real part will be first, the imaginary part will be next. Look at letter I. 9 plus this square root of negative 144 simplifies as 12I divided by 6. Notice that this number all divided by 3. Okay? This is more of what we did yesterday with your operations with complex numbers. Add, subtract, and multiply. I'm turning the page here. Where are we at? Okay. This letter J, remember we learned yesterday that you can add the real parts together. So 3 and a negative 7. The imaginary parts, 5I plus 8I, 13I. And then letter K, 6 plus 2I times 6 minus 2I. 6 times 6 is 36. 6 times negative 2I. 2 times 6. 2I times 6 is positive 12I. And the last part is 2I times 2I is negative 2I squared. Remember the very important thing we talked about, that I squared is negative 1. So that's going to become a plus 2. No, it's not. That's going to become a plus 4. I can't multiply today. Let's go back and take that out. What we're multiplying is 2I times 2I, which is negative 4I squared, which is positive 4. The i's cancel. 36 plus 4 is 40. Okay. All right, that's more with simplifying with the imaginary number. Okay. A review again of what we did yesterday. This part talks about complex conjugates. The conjugate of a complex number has the same real part, but the opposite imaginary part. Hear that again. The conjugate of a complex number has the same real part, but an opposite imaginary part. So to find the complex conjugate, you're going to keep the real part the same and change the sign of the imaginary part. Okay, it says tell the conjugate of each complex number. 25 is only a real part. Real parts stay the same. Letter M says 25I. 25I is an imaginary part. Imaginary parts change sign. N is negative 3 plus 6I. To write the complex conjugate, the real part stays the same. The imaginary part changes sign. So it's almost like an opposite. Letter O. The real part is negative 12. It stays the same. The imaginary part is negative 5I. It's going to change sign to a positive 5I. Letter P. The real part is 2/3. It stays the same. Imaginary part, negative 1/5 I, changes sign. Q. The real part is 5. It stays the same. Imaginary part, I square root of 3. It changes sign. Okay, good to go? Now to the solving part. So some quadratic equations can be solved by isolating the variable. We've solved by taking square roots before. This is just going to have an I in it. Okay, so what are we going to do here? We're going to move the 96. Divide both sides by 6. You can do this when there's an x squared term, but not an x term. Was that negative 16? Yes. Take the square root. take the square root. Plus or minus, how do we simplify that square root of negative 16? That's 4i. Okay. Why are they complex conjugates? Because you have the plus or minus with the imaginary number. All right, so what have we talked about? We talked about simplifying with the imaginary number I. We've talked about complex conjugates. With complex conjugates, the real part stays the same, and the imaginary part changes sign. We did enough of this yesterday with the simplifying that we're going to skip that part. This says, solve the following quadratic equations and describe the quadratic solutions. Again, these, do you notice that there's an x squared term and a constant, but there's not an x? So we don't have to use quadratic formula. We don't have to factor. We don't have to do any of that. We can solve by taking the square roots. So this one, we're going to divide both sides by 2. Well, actually, we would move the 50 first. And then divide by 2. And then take the square root. And you have x equals plus or minus 5i. 5 because it's the square root of 25. I because of the negative. Describe the quadratic solutions. They're complex conjugates. I wouldn't worry about this describe part. Let me see what we've got here. Yeah, those are complex conjugates because we have an I and we have both the plus and the minus. Look at number 9. We're going to move the 8. Divide by negative 3. Take the square root. 6 because it's the square root of 36. I because of the negative. Okay. Solving quadratic equations with complex numbers. 10 says, what is the quadratic equation with solutions of 7i? Do you notice how this was 5i and this was 6i? Okay. Remember we talked about factors and solutions have opposite signs. So if my factors are 7i and negative 7i, or those are my solutions, and my factor would be x minus 7i and x plus 7i. We're working backwards. Before we went from the equation to the factors to the solutions. Do you remember we had we had one that we did that was like x squared plus 6x plus 9 equals 0, and we factored it as x plus 3, and then the solutions were x equals negative 3 and negative 3. We're going to go backwards. Now we're starting with the solutions. We're working our way up. So here are the solutions. These are the factors. Now we're going to use FOIL and multiply together to get the equation. X times x. X times 7i is 7ix. Don't let that worry you. It's going to be all right. Negative 7i times x. And then negative 7i times positive 7i is negative 49i squared. Very important thing we learned yesterday. What's I squared? I squared is negative 1. That makes this a positive 49. What happens to these ugly old ix's in the middle? They cancel out, and you have x squared plus 49. Let me write it over here. That's your equation that has the roots of 7i. You might have could looked at the previous ones and figured that out from there, but we went from the solutions to the factors to the equation. Okay? This chart you already know about the discriminant. It tells you what kind of solution. If the discriminant is equal to 0, you have one double root. Here are examples. If the discriminant is positive because it's greater than 0 and a perfect square, 2 rational roots, 2 normal numbers. If it's greater than 0 and not a perfect square, 2 irrational roots. Here's examples. 5 plus or minus square root of 2. If it's negative, that's what we've been dealing with the last couple days. Negative is 2 complex roots. You're going to have imaginary numbers. Okay? So we have some sample problems. How many of those? Oh yeah, we're going to work those. And then your assignment is going to be these practice problems. Okay? 1 through 6. And then 7 and 8. They follow the sample problems exactly. The only thing you'll need to take a picture and send me, or work on your own paper, take a picture and send me, is these practice problems on the last page. Okay? All right, let's go through the examples so you'll know how to do the. This is for each problem. Write the equation in the form ax squared plus bx plus c equals 0. You have to put it in order first. It has to be in standard form. B says find the discriminant and use it to describe the nature of the roots of the equation. And C says complete the quadratic formula to find the solutions. All right, so look at number 1. Is it in standard form? It's not. We have to move the 2 over. So then we have 3x squared plus 7x plus 2 equals 0. What's A? A is 3, B is 7, C is 2. You can go straight from here to the formula. X equals negative B plus, can't have enough room to write there. X equals negative B plus or minus the square root. When you have a lag in your computer, that drawing doesn't work good. B squared minus 4AC all over 2A. Remember that? You can go straight from here, plug this ABC into that formula, and you've got it. Or you can find the discriminant first, which is because that discriminant is going to tell you, do you see this where it says find the discriminant, use it to describe the nature of the roots? This is 49. 4 times 3 is 12, times 2 is 24. So the discriminant is 25. That is positive and a perfect square. If you look back in the chart, it says that positive and a perfect square is 2 rational roots. That means we're going to have 2 normal numbers. They might be whole numbers, they might be decimals, they might be fractions, they might be positive, they might be negative, but nothing under the square root sign and no I. If this discriminant is positive and a perfect square. All right, so what do? We wrote the equation, we found the discriminant, now we're going to complete the formula. X equals negative B plus or minus the square root B squared minus 4AC over 2A. Square root of 25 is 5. 2 times 3 is 6. So I have negative 7 plus 5 divided by 6. And negative 7 minus 5 divided by 6. This is negative 2 over 6, which is negative 1/3. And this is negative 12 over 6, which is negative 2. So your solutions are negative 1/3 and negative 2. Doesn't matter what order you put them in. Those are your solutions. What do? We put it in standard form. We found A, B, and C. We found the discriminant. We used our chart to know we're going to have 2 rational roots. Put it in the formula. We solved it. Look at number 2. X squared minus 2x equals 2x minus 2. We need to put this one in standard form. So I need everything on one side made it equal to 0. So I'm going to have x squared. I'm going to move this 2x over, so it's going to make it minus 4x. Move this minus 2 over, make it plus. Next step in the instruction says find the discriminant, and describe the nature of the roots. A is 1, B is negative 4, C is 2. The discriminant is B squared minus 4AC. It's the part of the quadratic formula that's underneath the square root sign. This is 16. 2 times 1 is 2, times negative 4 is negative 8. 16 minus 8 is 8. You can also use a calculator for that step. Okay? Now what? We're going to put it in the quadratic formula and find our solutions. X equals negative b plus or minus the square root b squared minus 4ac over 2a. So negative negative makes a positive 4. That 8 I can break down to 4 times 2. Square root of 4 is 2. No. You can divide this one, and this one all by 2. You cannot divide the one that's under the square root sign. We don't need the one on the bottom. There's your answer. What do? We put it in standard form. We wrote down A, B, and C. We found the discriminant. Oh, we didn't write down what kind of roots. This discriminant is positive, not a perfect square. So we have 2 irrational roots, which means we're going to have something left under the square root sign. To me, it helps when you find that discriminant because you know what I'm looking at. I know if I should have something under the square root sign, or I know if I should have an I, or I know if I should just have normal numbers. To me, that's helpful. Okay, number 3. Let's put it in standard form. X squared minus 14x plus 58 equals 0. A is 1, B is negative 14, C is 58. Discriminant, B squared minus 4AC. This is 196. 4 times 58. I don't even have Siri to help me out here. 232. It's 36, negative 36. When the discriminant's negative, we're going to have 2 complex roots. That means we're going to have an I in our answer because this discriminant's negative. Here we go. X equals negative b plus or minus the square root b squared minus 4ac over 2a. That was b is 14, so negative b is positive 14. How do I simplify the square root of negative 36? That's going to be 6i. So now I have 14 plus or minus 6i divided by 2. Divide, divide, divide. I promise we're almost done. Okay. What are we doing? We're following the directions. We put it in standard form, which means the x squared term, then the x term, then the term without the x. Then we found a, b, and c. Found the discriminant, used the chart to determine the nature of the roots, and we plugged it into the quadratic formula. Okay. If you are in first period remote, you can stop here. You can keep watching if you want, but you can stop here if you want. Go to the last page, which is the practice problems, and do 1 through 6 only. Okay. Now, if you want a challenge, go ahead and keep watching. I'll do 4 and 5 here, and then you can work 7 and 8 for bonus points on your assignment. But if you want, you can stop here, go to the last page of the handout, page 6, and work the practice problems 1 through 6. Okay. If you're third period, the honors class remote, then hang with me. We got 2 more. Okay. Number 4 says, given a quadratic equation with rational coefficients and a root of 3 plus 5i, what is an, okay. You remember we talked about complex conjugates. So the complex conjugate of 3 plus 5i is 3 minus 5i. The real part stays the same. The imaginary part changes sign. When you have a complex number that's a root of a quadratic equation, the complex conjugate has to be also a root. So you can't have 3 plus 5i as a root without 3 minus 5i as a root. Okay, so another root to the equation is going to be 3 minus 5i. It's the complex conjugate of this. So now think about this. Our roots, or our solutions, are positive 3 plus 5i and positive 3 minus 5i. Those are the solutions. Remember, solutions and factors, we would flip the sign. So our factors are going to be x minus 3 plus 5i. Think of this as 1 unit, and it was positive, so we flipped the sign in the factor to negative. And x minus 3 minus 5i. Remember, think of this as that is the solution. It's positive, so in the factor it'd be negative. Now, this is what is the quadratic equation. What do we do with the factors? We multiply them together. So x times x times negative 3, x times negative 5i, okay. Now do the same thing with the 3. This will be negative 3 times x, and negative 3 times negative 3, and negative 3 times negative 5i. And then do the same thing with the 5i. 5i times x, 5i times negative 3, 5i times negative 5i is negative 25i squared. You know what? This negative 3 right here times this negative 5i is going to be a positive 15i. Okay, now we got to simplify. So let's look. We have x squared. The x's, you've got negative 3 and -3. The I-x's, you got a -5 right here and a +5 right here, so those cancel. The 15 i's cancel. What happens to this -25i squared? I squared is -1, so this becomes +25. And you got a +9 right here, which is +34. So your equation is x squared minus 6x plus 34. The roots of that are 3 plus 5i and 3 minus 5i. It made a long string of numbers there, but because you're multiplying the complex conjugate, the i's should cancel, the I-x's should cancel. And then your I squared is going to turn that number, it's going to change the sign, so you don't have any actual I in the equation. Okay? All right, we got one more. Okay, I'm going to see if I can make this a little better for you to see. This equation is what? Given a quadratic equation with rational coefficients and a root of -2 plus 8i. So the other root has to be -2 minus 8i. Now remember, this is a root or a solution. If you think about a sign here, that's positive, right? If this is the other root or solution, you think about a sign here, that's positive. So then your factors are going to be x minus -2 plus 8i and x minus -2 minus 8i. Again, we're thinking of this as one thing, one unit together, and the sign in front of it is positive. So when we put the factor, it's negative. Now we're going to multiply x times x. X you know what? Let's do this. See if that works a little better. I multiplied those things. Okay, so then we have x squared plus 2x plus 8ix. Now we're going to multiply the 2. So 2 times x, 2 times 2, 2 times 8i. Okay, we're good so far. And then multiply the -8i. Let's use a different color. -8i times x, -8i times 2, and -8i times 8i is minus 64i squared. You see what I did here? I took care of these negatives and simplified inside those parentheses. Then I distributed each of these 3 terms times each of these 3 terms. Now we combine x squared. That one's gone. What about the x's? There's 2x plus 2x is 4x. Now let's look at your ix's. They should cancel out. If they don't, go back and check your multiplication somewhere. 8ix and 8ix cancel out. 16i, -16i cancel out. This is going to become positive 64, and we're going to add it to this 4 and get plus 68. And that's your equation. It's a lot of numbers. All right, what I want you to do, if you're in the 3rd period remote class, is to go, there's the practice problems on page 6 of this handout. There are 6 problems. You can work those just on your own paper and take a picture, send it to me. On Thursday, we will review, and on Friday, we'll take a test. Have a wonderful day.